theory, we're live. I think we'll wait a couple of seconds just to confirm, but hello, everyone, if you're out there. I guess we'll go ahead and get started because I'm pretty sure we're live. My name's Alex. This is another edition of, what are we calling this, G1? Creative Coding with Codecademy?
Codecademy live series for creative coding. That's what I've been calling it.
Cool. Well, yeah, this is our sixth session. G1 has been leading all of them so far, but for the next two sessions, I'm going to be leading them a little bit. I have to warn folks that all of my projects are going to be about 100 times less creative than G1's. G1, I've been so impressed by, like, you're coming at this really from the creative coding artist angle. And I actually think my sessions are going to be slightly different in having limited creative capabilities, but kind of focusing on programming fundamentals.
I'm hoping throughout the series, I can maybe give you a little bit of like, oh, what if we do this sort of suggestions?
Yeah, for sure. I guess as a little bit of background in setup of what we're doing today, I used to be a high school teacher. I used P5 in the classroom. And in addition to using P5 to make really amazing pieces of art and do creative coding like G1 has been doing, I think P5 is an awesome tool just to teach programming fundamentals. So today's session is going to be all about object-oriented programming. What is a class? What is an object? How can you start to think about designing your programs in an object-oriented way? I think what's especially cool is that I'm not even really a web dev guy. Like, I don't know JavaScript that well. I certainly don't know CSS that well. So even though P5 is JavaScript based, again, the things that I really want you to focus on as you're watching this session are the fundamental concepts, because these concepts are going to translate to Java or Python or JavaScript, like we're going to see today. But it's the concepts that are important, not necessarily the syntax. So going into that again, G1, as someone who has way more JavaScript experience than I do, I'm sure I'm going to be doing things today that are like not super official or JavaScript style, or it's going to be weird, right? So maybe I can even learn a little bit from you today if you want to call out like, hey, that's not how you declare a variable, or you're forgetting all of your semicolons. What are you doing?
I will try, but also I do have, like, I think if it works, it works. I think one of the beauties of using V5JS is that, you don't have to be too bogged down on the little syntaxes, and like you can really use it to try out, computer science concepts that may not have given you that visual click, but that the V5JS will give you that. And we'll get to see some of that too today.
Exactly. I see we have the chat open. I want to definitely make this as interactive as possible. I have kind of an outline of what I want to build and what I want to show off, but there's a lot of different ways that we can experiment and go in different directions. So as I'm doing this, feel free to ask questions or make suggestions or experiment along with me. Finally, last thing to say before getting started is I will post solution code in the YouTube description. Basically, the code that we end up with, I'll post in the YouTube description after the fact. So if you're watching this in the archives, go ahead and check the description if you want to have access to the code that we ended up with. Cool. Okay, so let me give a brief preview of kind of what we're going to aim for. Again, I doubt we'll end up with exactly this, but this is an idea of what we're aiming for. So falling raindrops here. And the key piece of insight here is that each of these raindrops is a different object. So we'll talk about what that means, what an object means, what a class means, all that kind of stuff. But this is around what we're going to be aiming for. So I'm going to stop that. I'm going to come over here and open up a blank P5 canvas. And what I want to do before getting into object-oriented programming is first doing something similar, not object-oriented. So kind of following things that we've been seeing with G1, doing some of our basic P5 functionality that you should know by now if you've followed this series, and do it in a non-object-oriented way. So first thing that I want to do is let me just set up a single ball that is going to be falling. And so to do that, I'm going to set up some variables for the ball's position. So I'm going to put the ball at 100 in the X direction, and let's say 200 in the Y direction. And let me draw that ball at X, Y, and let's make the radius something like 20. Just make sure that that works. Cool, there's our ball. To make the ball move, what I need to do is I need to start modifying this X variable in the draw function. So again, a little bit of a recap, the draw function gets called again and again and again in V5, where I think it, by default, it gets called 60 times per second. So in the draw function, if I say X equals X plus 1, this ball is going to move in the X direction. So it's actually not even going to fall. It's going to move horizontally. And when it gets to the edge of the screen, it's just going to keep going, right? You can imagine this X variable. It started at 100. It reached 400 eventually, and then it went above 400. So it's at 500 now, maybe up to 600, which might be something that we want to change. So I can actually do a little bit of a trick here. I can use some mod arithmetic to say X equals X plus 1 mod 400. Jiwon, I think you might have talked about this a little bit in some of your sessions, but how does this mod work, and why does this kind of help the ball reset back to the start of the screen?
Yeah, we looked at Modulus in our last two sessions. The first time we mentioned it was during the generative art tool creator project, and we also used it last session when we were creating the digital sculptures. But basically what Modulus does is that it takes the operand on the left side of the symbol and then divides it by the operand on the right side of the symbol. So in this case, the first time when it loads will be when the left operand is 101, and it will divide it by 400. And what will return is the remainder of that division. So basically what moduluses are generally used for is if you have, if you want to limit a range, like in this example, the way that Alex is using. So they will ensure that whatever that first operand, that first number may be, that will stay within 100 and 399 actually, because if it's 400, it will fit into 400 by 1 and the remainder will be 0. Another way that you can use Modulus is to basically fit everything into a fixed number of categories. So you can use it to do something like, you know, if you want to divide that into, you know, in this case, it will be a little bit different, but if you do modules by 3, then you can do 1, 2, 3, 1, 2, 3, 1, 2, 3 for each step of that ellipse moving. But 1 pixel at a time. So you can do something like that too. And doing the categorization is actually the thing that we use Modulus for in our 2 previous examples. So actually, this is really great. It's a new way of using Modulus.
Cool. Yeah, and I wanted to give a little demo here as you were explaining it. We can even see if I change this slightly, X is now going to continue to increase. So if I log X here in the console, you'll see there's my X increasing. And I never actually change X to be below 400. But what I do is I draw X at whatever X is. So at this point, it's up to 700, 800. But then I mod it by 400. So that's going to keep that range in between 0 and 400. So this is a nice little trick that as you're developing your program, I see Sunita asked a question of just, can you give us some tips? This is a really useful one of basically use print statements to investigate what your variables are doing. If you have a bug, oftentimes printing something out, taking a look at what these variables are is a really good way to see what's going on. I'm going to change this back to keep X between 0 and 400. Just for ease, I mean, again, as you were saying, Jiwon, like the output is really kind of the thing that matters. There's a bunch of different ways to do this, but now I know that X is always going to be between 0 and 400. Cool. So this looks like one of the balls that we saw on our kind of completed version. I guess it's moving horizontally and not vertically, but you know, we would just have to change the Y variable in order to get to move vertically. This isn't quite object-oriented programming yet. And in fact, let's modify this now. So rather than only having one ball, let's set up 100 balls. And so I'm going to take these same ideas and I'm going to say, OK, rather than just having a variable for one ball, an X variable and a Y variable for one ball, I need to have 100 variables for each of those things. And one thing that I could do is I could list out 100 variables, right? I could have let x2
Oof.
equals 150, and then I could tell it to draw at x2. That obviously is going to take some time and probably something we're not interested in doing. So another really fundamental idea in computer science is we're going to use, G1 in JavaScript, is it called a list or an array?
It's called an array.
Okay, cool. So we're going to use an array. In Python, they're called lists. In Java, they're called arrays as well. But we're going to use an array, which is going to hold 100 variables for us. I'm going to actually do something a little bit new here. In order to populate this list with 100 different values, I'm first going to use a for loop. So again, if you're not familiar with for loops here, don't really worry about what I'm doing. Again, the idea here is that I'm just populating this list or this array with 100 different values. And again, that's, we have tons of courses on what for loops are, how to get comfortable with them, but not really the core thing that we're interested in for this exercise. For this exercise, we're eventually going to look at object-oriented programming. Okay, so let me add to my arrays here. I'm going to add to the X array. I'm going to do X dot, is it push, G1?
Yes.
Adding to an array in JavaScript. Cool.
Mm-hmm.
So push, if I put in 10 here, and let's do Y dot push, I'll actually put in 100 and 200. I'm going to put in, well, let me even change these values. I'm going to put 500. I'm going to put the value 500 into my X array 100 times. This loop is going to happen 100 times. I'm going to keep putting the same number in again and again and again. I'm going to put the number 200 in the Y array 100 times. I'm then going to, rather than draw just one array, or just one ellipse, I'm going to draw 100 of them. So I'm going to put this code that I had before in a loop. And now, rather than drawing the ellipse at X, if I do this, this is likely going to crash. It might do something weird, but we can take a look at what it does. Cool. Yeah.
Also, I was going to say, the other thing, Alex, your X is starting at 500 and your canvas is 400.
Good call. Let me start that at 300 then.
And let's also see what else is going on. It says ellipse was expecting number for parameter, but it did not get that. Oh, well, the other thing that you're not doing, I guess, is you're not using an element inside the array. You're referencing the whole X array and whole Y array.
Yep, exactly. So here, before, when X was storing just a number, this worked because I could plug in my number for X and I could draw my ellipse at 100 or whatever X was. Now what I'm saying right now is draw my ellipse at X, and X is this array that has 100 numbers in it. This ellipse function, has no idea what to do with that 100 elements. So instead, what we want to do is we want to say, let's draw our ellipse at the ith element. So the first time, and I'm going to do that for all of these, the first time this loop happens, we're going to grab the element at the 0th position of the array. The second time the loop happens, we're going to grab the element at the first position of the array. Again, loops are not the main focus of this session. So if that's confusing, I would say largely don't worry about it. We're going to kind of breeze through that and get to object-oriented programming in a second. But that's the idea. We're going to grab each of our 100 different elements one time, and we're going to draw an ellipse. And G1, what do you expect to happen now if we run our code?
We should see all 100 ellipses appear in the exact same spot and move exactly at the same time.
Yep, exactly. They're all going to be right on top of each other because they all have the exact same X and Y dimensions. So this is another kind of little new thing that I want to introduce. In order to solve this, we're going to use math.random. And it's going to look even slightly more confusing than just math.random. We're going to do math.random times 400, and I'll show you what that does in a second. But before we do that, let's take a look at, there we go. There's our 100 different balls.
So
yeah.
Here we're using the math.random function, and that function is a vanilla JavaScript function, what's called vanilla JavaScript, meaning that it's a native JavaScript function. But V5JS also has a random built-in function.
Ah, cool.
So you can just say random, and inside of it, you can give it one argument, which will be used for the maximum value. You can also give it 2 arguments in there. So you can define minimum and maximum point. But in this case, if you're going to do a random between 0 and 400, you can just put in 400.
Cool. That is way easier. So this is now giving me a random value between 0 and 400.
Random decimal number.
Random decimal number. So in fact, let me print out. Let me print out inside this for loop. Console.log x of I. So I'm going to be logging the numbers that are inside this X array. And there they all are. So there's my random decimal number between 0 and, 0 and 400. So you can see this is what's currently in our array. Cool. Let me get rid of that print statement.
I don't know how nerdy this is going to sound. It almost makes me, this feels like watching like water particles move from one end of the hose to another end of the hose.
Yeah, or like when you're in the car and you're watching the water like drip down the window.
Yeah.
Yeah, cool. Let me take a peek at the chat. What is object-oriented programming? Cool. New username BRB. So that is what we are going to get into right now. So far, we've kind of done the goal, right? Again, let me show you what the goal is. The goal is something that looks like this. There's some color that we haven't added yet. There's some size stuff that we haven't added yet. There's some speed stuff that we haven't added yet. But for the most part, it's there, right? We have balls that are moving across the screen. What we're going to now do is we're going to transform this into being object-oriented, which means that we're going to start thinking of each of these balls as a specific object in our code. So right now our code doesn't really have a sense of objects, right? We just have these giant lists of X positions and Y positions. And it's a little bit hard to, I get, object-oriented programming is just a style of programming. This obviously works, but we're going to investigate what it means to build something through object-oriented programming. Let me talk a little bit about what object-oriented programming is first, and then we're going to implement it using these raindrops or these bolts. So the main idea of object-oriented programming is we're going to section off some of our code into attributes and methods or functions. And so sometimes I like to think of these as the nouns and adjectives and verbs of an object. So Jiwon, what is something that is currently in your room? Let's do a little experiment of turning that thing into an object in object-oriented programming.
I've got a plant.
Okay, cool. So you've got a plant. So if we were to represent a plant as an object in code, we would want to think about what things belong to the plant. And so again, those are like nouns and adjectives associated with the plant, and what can the plant do? So those are the methods or the verbs associated with the plant. So
I wish I had some pet in the room right now, something that has more dynamic action, but
yeah, it has more verbs. Well, so the verbs in P5 are going to be a little bit strange because it's going to be like display yourself, which I suppose you could say that the plant is doing, where the plant is like existing in the world. Yeah. But some like more obvious things, I guess, a plant could grow, right? That would be changing a certain attribute about it. Let's talk about what are the attributes of a plant. What are some nouns or adjectives associated with your plant?
So it can have leaves. More specifically, it can have number of leaves. And then there will be also the height and the width of each of the leaf, or the whole of the height and width of the plant itself as well. There's also going to be things like, does it have flowers? Does it bloom? Does the plant bloom? There's also going to be colors, things like the color of the flower, the color of the leaves, that kind of things. And, if we're talking about the whole plant as an entity, like what's the pot size that we need could also be like a numeric number that will be an attribute for this particular plant that I have behind.
Yeah, so that's a great example. And I love that you gave me attributes that are all different data types, right? You had some numbers, how big is the pot, how tall is it? You had some strings, like what color is it? You could imagine that being represented as a string, or what is the name of the plant? And then finally, you had some Booleans, some things that are either yes or no, right? Does this plant flower? Does this plant currently have flowers? Things like that, things that are either yes or no. So I'm going to pose this question to the chat, and I know chat is like 30 seconds delayed, so we will have to keep talking as they try to answer this question. But thinking about what we currently have, and again, looking at our final output, what are some of the attributes to these raindrops, right? What are the nouns and adjectives associated with these raindrops? And I'll pose that to chat. And in the meantime, Jiwon, can you give me a noun or an adjective associated with these raindrops that you think I haven't coded in yet? Like, what else could we add to these raindrops that doesn't look like it's already there?
I think that's not already there.
Mm-hmm.
Okay, this is difficult. Because we've already got, okay, I don't also want to think out loud a little bit, because I feel like I'm going to give away the answer that we are expecting people to write on the chat.
Mm-hmm.
I think opacity could be one, even though something is already related to that. But I think also opacity could be calculated based on the size.
Mm-hmm.
So that could be actually really interesting. You can create like almost like a 3D effect with that, I think.
Yeah, I think that the way that you were talking through that gave me an interesting thought of you can kind of tell the things that I haven't coded into these raindrops are the things that they all share. So opacity are all the same, right? They all are perfectly non-opaque.
We can also,
shape is something that's also the same, where every raindrop is a circle. So that's an attribute that I'm probably not really keeping track of. Maybe all of these raindrops know that they're all circles, but that would be a little bit silly if every raindrop in the world is a circle and they all know they're circles. So
it's actually interesting because you kind of frame this as raindrops. So I immediately thought, oh, like all of these should be circles, but raindrops don't have to be squares. If you're in Minecraft, they might actually be cubes, not circles. So
yeah.
Other things I think we could do are maybe we could do like individualized movement within it as well. So, we've got everything falling and it looks like they have different speeds of falling, so different Y speeds, but I think we could also make it do like a little bit of jittery motions as well.
Yeah, and that's interesting because that kind of combines, right now we're focusing on just the attributes of what are the qualities of this object, what are the nouns and adjectives associated with it, but then falling is definitely a verb. And so that's starting to like blend the two of maybe some of these raindrops have an attribute of like, I'm a fast faller or I'm a zigzag faller or something. And then that affects how the fall method or function gets called, or that affects the verbs associated with that raindrop. Cool. Well, it looks like nobody is answering us in chat, which is very sad. But Jiwon, what are some of the attributes here that you think do exist for these raindrops?
So a really blatant one here is color, right? Every raindrops have different colors, and we've also got different sizes. And they've also got different X and Y positions as well, because I assume they start off on different X position, and the Y position is actually individually kept track of, it seems. And they've also got different rate of falling as well, because I see some things that are kind of together at that moment in time, and you keep looking at it, one falls faster than the other or slower than the other, depending on which one you're focusing on. So I think those are the main things I see.
Cool. So let's go and write that down over in the code that we're building. So we had, these are the attributes, and oh man, I don't even know how to comment in JavaScript.
Yeah, that's
is
it.
Yeah.
Yeah.
These are the attributes of a raindrop, or at least the ones that is already coded into our final solution that we were seeing there. So we had, yeah, I saw not myself just said size. We had an X position, we had a Y position, we had a color, we had a speed. I suppose, yeah, again, like we had a shape, even though they were all the same, that's something we could consider adding. Yeah, I think that is, oh, we had a, yeah, size is already in there. Okay, cool. So these are the attributes of a raindrop. Cool. How about actions and attributes? I'm gonna again put noun / adjective of a raindrop. Actions are the verbs that a raindrop can do. I see a question in the chat, what language? This is currently in JavaScript using P5, which is this kind of visualization library that JavaScript has. Cool. So what are the actions or verbs of a raindrop? What can a raindrop do, Jiwon?
They fall.
Yep.
But they also, I don't know, is it cheating if I go back? If we go back to the other?
Yeah, let's take a look.
It does seem like also when they go down, they're coming back up as well.
Sure. So they like reset somehow.
Mm-hmm.
Yeah, because you can see, yeah, let's catch one at the bottom. That blue one then pops up there. And you could even, I don't think I've coded this into the solution code, but you could imagine when they reach the bottom, they have a new X position where they can like jump around when they reset.
There's also a comment actually came in from chat from Archie that's saying that there's also seems to be layers in the frame. That is actually really interesting. Right?
So that's like, what is that called? Like the Z level, right? Like how far forward or back the object is?
Well, I think that's sort of like the way of thinking about it. If these were individual, each of those were like HTML elements, for example. But what is actually going on in here is because an ellipse is drawn one after the other. So the topmost element or the topmost ellipse that's being drawn on this frame is the ith element in the array, actually, right? Or the ith object in the array. And the one that's going to be furthest back is the one that's drawn last in the draw loop. So it is creating, like this stacked effect, but not on purpose, if that makes sense.
Yeah, but I mean, we could think about ways in which if we wanted one ellipse to always be on top of the others, we could think about ways that we could do that. But yeah, that is slightly trickier just based on how drawing things on top of each other works in P5, where, right, what Jiwon was saying was the first ellipse that gets drawn in this for loop is going to be the one at the very bottom, and then any ellipse that comes after that, if they happen to overlap with that other ellipse, are going to be on top. So that is happening kind of as a side effect. But we could think about how we might be able to do that, or how we might be able to code that into our object. So like,
yeah, that'd be fun actually.
Layer, is that called Z? What is that called? Z?
No, I mean the CSS term is Z index, but in this case, I would just call it layers.
Okay. Cool. Cool. So let's think. There's one more important verb, very specific to P5, and I kind of hinted at this with the plant. But another thing that these raindrops are doing is they are displaying themselves, right? I could create these raindrops. These raindrops could exist in the code. All of their variables could be changing, and then I could just choose not to draw them. We could see that if I do this right now in the non-object-oriented version of this code, the displaying of it is kind of equivalent to calling this ellipse function. And so I just ran my code. All of that stuff is happening in the background. All of those, all of these values are changing. The modulus is happening. They're all staying between 0 and 400, but they're not being displayed. And so that's kind of a weird verb or method of these of these raindrops that's not immediately obvious. So display self. Cool. One thing that we could do that actually haven't built into this, but we will try to do it if we have time, is some sort of clickable event. So a raindrop could like detect that it's been clicked and then change color or do anything really. So it could like detect clicked.
It could almost be like a game. It's like one of those like catch objects falling sort of game.
Yeah, for sure. It can like, yeah, a raindrop might be able to detect where it is. And then if it's, you know, in the basket, then you score a point or something. So like, you know, detect in basket could be a function that could be a verb that a raindrop could do. Okay, so this is kind of the outline of how we start to turn this into an object-oriented approach to coding this out. And so now that we've kind of conceptualized it, let's actually start building this out. And the way that we do this is by building a class. And let me actually even look at, yeah, so the way that you do this in JavaScript is I'm going to build a class Raindrop. In object-oriented programming, the class is kind of like the blueprint of the objects that you're going to make. So in fact, we're basically going to kind of fill in the details of everything that we just talked about. We're going to define this class, this blueprint, and then we're going to take that blueprint and make a bunch of objects. We're going to make the raindrops themselves and make the raindrops display themselves and make the raindrops move. We're kind of going to first define the blueprint for doing this stuff, and then we're going to put that blueprint into action and make real objects. So that's kind of the distinction between a class and an object. The class is the blueprint, it's the setup, it's what does it even mean for a raindrop to exist, and then the object is let's make a raindrop exist. Now that the class is defined, let's actually make one. It's an instance of a raindrop. So cool. Let's start by defining the constructor. And Jiwon, this is where your JavaScript knowledge might come in handy. I'm going to be defining all of my attributes inside. I'm going to be defining and giving initial value to all of my attributes inside the constructor. Is that typical, or does the defining of the variable typically happen outside the constructor?
It should happen inside the constructor with the this dot keyword, which I'm sure you're going to get to. But basically, the constructor is also a method of the raindrop, and it runs when an object of that class raindrop is created, right? So I think in a way, it almost is very similar to how the setup function runs within V5JS, right? It will run one time only when an object of the raindrop class is created.
Cool. Okay, yeah. So yeah, the job of the constructor is to give these attributes initial values. So we're going to create a raindrop and give them initial values. So let me first list out all of these attributes that we want and give them a variable name. And I'll talk about what this dot word actually means. But let's give these some variable names. So I'm going to just say x position, this dot y position, this dot color. I'm actually going to break into 3 variables. I'm going to break into an R, a G, and a B, a red, a green, a blue value. So color is a little bit, I mean, we could do one variable, but we're going to be able to do, I guess, more interesting colors if we break it out into 3. We do this dot speed. And for now, I'm going to pass on these. I'm going to just say every raindrop is going to be an ellipse. And so I don't need to build that into the class itself. And I don't want to think about layering right now, although I'm sure we could come up with something cool if we had time, or that's a good extension if you want to play around with layering.
I think we are missing size.
Oh, good call. Yes, this dot size. Do you want to explain what this keyword means? It's hard.
Okay. It is a little bit hard, but basically what this keyword does, and the this keyword isn't just unique for JavaScript only. Well, it is a JavaScript thing, but it's not just for a object-oriented programming thing only. You will also see this being referred to when you're doing a DOM event or like a DOM detection as well. Basically, what that means is that this keyword indicates the particular instance of the XPOS property or the attribute that belongs to that particular object. So what that means is that if we create, let's say 3 raindrop objects using the class raindrop, the particular this within the blueprint will refer to that the one specific object's X position attribute, Y position attribute, and so on. And it's commonly basically used to individualize these values or these properties per object that we're going to be creating.
Yeah, exactly. So again, we're going to be creating 100 raindrops. Each one is going to have its own X position, its own Y position. It's going to have its own, each one of these attributes is going to have its own one of those. And this keyword, we're going to be able to say, I want to specifically look at that raindrop's X position, or that raindrop's X position. And we need to know that those 2 X positions, even though they're both named X position, belong to certain raindrops. And so that's the idea behind this. It belongs to this dot X position, XPOS belongs to a specific raindrop. Cool. Yeah, this is always really tricky to conceptualize, and I think it will become a little bit more clear as we start to make raindrops when we start actually use the blueprint. But if you have questions about this, definitely drop them in chat, and hopefully by the end of this session, it'll make a little bit more sense. Cool. So the constructor is almost done. We've defined our variables. We know what variables we want, but the other job of the constructor is to give them initial value. And so something that I'm going to do here is, again, use that random function. I'm going to say, whenever the constructor is called, meaning whenever we make a new raindrop, we are going to set its X position to a random value between 0 and 400. Again, I'm going to hard code in. I'm not going to hard code in. I'm going to, let's see. I'm going to say let the height of the screen is going to be 1,000, and let the width of the screen also be 1,000. There's probably I could probably do this in a different way. Like, these are now global variables, which I imagine are not super loved by everyone. But we're just going to roll with it. So width and height. And then this is going to be width, height.
Maybe just as a reminder, you can also use the window width and window height global, the built-in variables, to make it the exact size of your preview window as well. And also, if you want to refer to width and height of the canvas itself, you can also use the width and height built-in variables too.
So something that's a little bit weird there, though, is don't those variables only exist after setup has been called? Basically, I want to use width and height inside this class.
You should be able to use that in there.
Interesting. Okay, let me back up then, because that's definitely the better thing to be doing rather than setting up those variables that we don't need. I'm going to start by hard coding in 400, and then let's play around with. So you think I can just do width right there?
You can. It's just you might have to move the class definition at the end, but I don't think you even need to do that, because what it will do is that regardless of where your code is defined, P5JS library will just look for a user-defined setup function, run that, and then run everything else after. But let's see what happens if you do that. And then if not, I know that you can do it. It's just whether that class will have to be defined after the setup function in terms of where in the line of code, that might, I'm a little bit faint on that. So.
Okay, cool. Yeah, let's leave it like this for now. It's going to be a second until we run our code anyways. And if things break, we know we can go back and hard code in 400 for now. But that's something we can eventually look at. For the colors, I'm going to do a random number between 0 and 255. Again, I think G1 dropped a link about color in the chat. can look into how colors work. But basically, if this number ends up being high, close to 255, then there's going to be a lot of red in my color. If it ends up low, closer to 0, then there's going to be less red. And same thing for green and blue. And I guess, could I do 256? I mean, it really does not matter at all, but is it, I guess 255 is what we want here, yeah. Cool. Speed, for now, let's just say every raindrop has a speed of 1. And for now, let's say every raindrop has a size of between 1 and 1 is going to be really tiny. Let's say it has a size between 10 and 50. Okay, cool. So at this point, we've kind of dealt with our attributes of our class. A raindrop, we can now start creating raindrops using the constructor. And each of those raindrops is going to have, a lot of these attributes. We didn't quite get to shape or layer, but they're going to have those attributes. We haven't done the verbs yet, but let's go ahead and actually use this constructor because we can do that at this point. So I'm going to delete these arrays, and I'm going to delete all of this as well. And now, instead of having these separate arrays for the separate attributes, where again we added here's my array of 100 x values, here's my array of 100 y values. You can imagine if I wanted to start doing colors, I would have to say, here's my array of 100 red values, here's my array of 100 green values, here's my array of speeds, right? It starts to become super cumbersome when we're defining all of these different arrays for all of our different attributes. And
Sorry, I want to point out that we actually did something like that for our second live stream session. We created these, like, they're not exactly bouncing balls, but they are a little bit bouncing balls actually. That started from the middle of the screen and then went around and then bounced around the canvas. And the way that we differentiated for each of the ellipses in the bouncing ball is by having, I think we had like, 6 or 7 different arrays for each of these attributes, which I guess is the thing that we're addressing here, the benefits of using object-oriented programming versus having a lot of arrays for each of these.
Yeah, and you can kind of imagine if our program got bigger and bigger, now these arrays that are very specific to the raindrop are going to start mixing with things that are like irrelevant, right? We're just going to have like the array containing the speed of the balls right next to something that's completely unrelated. And so by doing this object-oriented programming approach or object-oriented approach, what we're doing is we're containing all of the information about raindrops inside the raindrop class, and nobody else really has to worry about it. All you need to know how to do is create a raindrop, and the position, the color, all of these things are going to be kind of taken care of for you, or at least it's going to be sectioned off into its own part of the code. So let's look at, let's now create a list of raindrops rather than a list of, or an array of all of these different features. So
Alex,
same as before.
Want to say let before raindrops.
Thank you. Yeah. There's some of my JavaScript experience coming in. Yep, so defining my array of raindrops to be empty. And then here, where before we had, let me Control Z because I'm upset with myself for deleting all that code. So let raindrops equals that. And here, before we had, let me push on a random number to my X value array. Let me push on a random number to my Y value array. Now we're only going to have one of these because we only have one array we care about, and that's named raindrops. And instead of just pushing a number onto our array, what do we want to do, Jiwon?
We want to create a raindrop object and then push that object into the array.
Correct. So this is us actually using the constructor. And let me make sure I have the syntax of this right, because again, this is kind of different in every language that you use, but it's creating a new raindrop.
Mm-hmm.
So what this is doing is, there's probably subtleties to the new keyword that I don't actually know, but the way in your introduction to object-oriented programming lesson, the way that you should be conceptualizing this is I want to go to the Raindrop class and find, which is the class that we defined right here, and find the constructor with no parameters, right? That's why we have open close brackets right here, and do whatever that constructor does. So in this case, I'm going to create a new raindrop and set up its position, its Y position, its red, green, blue values. Juwon, does JavaScript allow for multiple constructors with different parameters?
That's a good question. I believe you shouldn't be able to do, but let me quickly look that up.
Yeah. As she does that, I guess I can give a little bit of an explanation of other languages enabling you to write multiple constructors. So some constructors want like a variable here, right? And that variable might define the range in which the size could be, right? I could like put that there. So other languages allow you to define multiple constructors, and then when you actually call those constructors, you would have to, make sure you know which constructor you're calling. Where if my constructor took a variable, then I would have to give it a variable in order to call that one. But again, differences between different languages. Yeah.
I think the answer is that if we're using, the thing with JavaScript is that this is what's called an ES6 way of defining, it's a version of, ES6 is a version of JavaScript, and it's that way of defining classes in ES6 JavaScript, the latest version of JavaScript. You should be able to use prototyping. This is like getting a little bit too much into the nuance of things, but basically the short answer is if we're using this pattern, no. But if you're using another pattern, yes, you might be able to.
Yeah. So again, kind of something to think about as you're working with object-oriented programming is that there's different ways to create different constructors. And the way that I am doing this right now, we're kind of stuck with this default constructor with no parameters, which is totally fine for our purposes. Let me, now that this raindrop exists, let me actually, I don't even know what's gonna print out here. I bet it's a bunch of objects that aren't gonna be helpful. Let me log what my raindrops
it should be
array
helpful.
Actually looks like. And that should be fine. So if yeah, cool. I have an error here because down in my draw method, I'm still using X, which doesn't exist anymore. But the thing that we're interested in here is my array of raindrops. So it's 100 of them. And now I can start to actually inspect each of these raindrops. Look at this. This raindrop has its own X position. Sounds like I'm saying X position. This raindrop has its own X position, its own Y position, red, green, blue values. And this raindrop has its own variables. So each one of these has its own variables. The reason why they're different is we're using this random function to say when I create a new raindrop, give it a random value. So that's awesome. And the console.log really helps there to see all of these different raindrops, and they all have their different values. Cool. So we are set with attributes. We can create raindrops and they can have their own attributes, right? They all have nouns and adjectives associated with them. Let's now write some actions, some verbs, things that the raindrop can do. And so again, if I'm comparing back to what I had before, all of the actions I was doing down in the draw loop, right? I was drawing the circle. I was using the ellipse function to draw the circle, and then I was moving the circle down here in the draw function. And so what we're looking to do is we're looking to kind of move some of this code away from the draw function and bring it into our class. So let's start that by defining the display. Let's say a thing that a raindrop can do is it can display itself. So I'll even call it display self. This is a method of the raindrop class. And we have to ask ourselves, okay, what does it mean for a raindrop to display itself? That a raindrop displaying itself means calling ellipse at its own x position, its own y position, and oops, I need to do this dot y position, and size, this dot size. Cool. So I can display a raindrop. Let's see. Let's put that into action. So down here in my draw loop, I'm going to, instead of calling ellipse here, I'm going to say, grab the raindrop at position I, and it's called raindrops at position I. Again, that's our array of raindrops, and have that raindrop display itself.
Whoa!
Cool. There they all are. So again, kind of that similar idea of, I don't really want this code about displaying a raindrop just kind of floating in the draw function where it could be interacting with any other code I write here. It's really specific to raindrops. And so let's just section it off into the raindrops class, right? You could even imagine somebody coming along, I hand them this raindrop class, I say, a raindrop knows how to display itself. Don't worry about how it's doing it. You don't need to know anything about its x position. You don't need to know anything about its y position. All you need to know is that it can display itself. And so go ahead and make it display itself. And somebody could come along and make it do that.
Actually, one thing that we should circle back into is that the random width is working up there.
Yeah, there you go. Yes, this is working where the random width is getting between 0 and 400. So if I increase this to 1,000, we should hopefully see, yeah, these raindrops are spread all along, all along my canvas, even past 400. So that is definitely working. Let me shrink the canvas to maybe 500 by 500. All right, we got 8 minutes left. So let's do, okay, an aspect of displaying itself is setting the color. So before I draw the ellipse, I'm going to set the fill, which is fill is kind of like setting your paintbrush for all future shapes. So I'm going to set the fill to this dot R, this dot G, this dot B.
Whoa.
Cool. Do you want, why are they different colors? Given that I just said fill sets the color for all future shapes. Like, how are we getting a bunch of different colors if fill is saying any shape you draw from now on is going to be this color?
Because when we created the object in line 40 by saying new raindrop, it ran, if we go back to the code in the constructor, in line 22 to 24, we're randomizing the RGB values. So basically, each of our raindrop have different value for red, different value for green, different value for blue. That's going to range between 0 and, well, technically a little under 255, right? The highest number it can get to is 254.9999. But that just means that we're eliminating the chance that the raindrop will be completely white. That's okay for our purposes. But basically, because of that, when we draw it in display self, each of the objects are going to have a different R, G, and B value. So they're going to be using different fills in there. And every time that ellipse function or the display itself function runs, a new fill color set, and then the ellipse is drawn. And then next time a new fill color set, and then the ellipse is drawn, and so on.
Yep, exactly. So because I'm going through this for loop, the first raindrop calls display set. We say every shape from now on is going to be filled with that first raindrop's color. Let's draw a shape. Then the very next thing that we do is this loop happens again. We tell the second raindrop to display itself, and we basically overwrite that first fill command from the first raindrop. We say, forget about that. From now on, any shape we want to draw should be filled with this color. And then we set the ellipse, and that happens again and again. One kind of side effect here is that if I started drawing shapes after this for loop, they would all be drawn in the color of the final raindrop. of that set. So if I just draw like a rectangle at 100, 100, that's 50, 50, you'll see that this is filled with whatever the last raindrop was, which looks like maybe that's the last raindrop.
Oh, that's cool. You can spot it.
Yeah, in fact, here we can, this is like super overkill and something I shouldn't do given that we have 5 minutes, but we can see, yeah, the raindrop at X at 4, what is that? 439. So that's far over to the right. Yeah, so it looks like it's that raindrop, which is kind of cool. But yeah, kind of a side effect to remember is that we never like clear that fill. So something that we could do here is then say, great, after I'm done drawing those raindrops, let me set the fill to black or whatever you want. But just be aware that this is changing the fill kind of without you realizing it. Cool. All right, you got 4 minutes left. Let's implement the other big verb here of fall. So a raindrop can fall. And for a raindrop to fall, what that means is that we want to change the y position by its speed. So this dot y pos plus equals, or I don't even know if plus equals this. So this dot y pos equals this dot y pos plus this dot speed. It'll be more fun if we give each raindrop a random speed. So let's do between 1 and 10. And then I know we said kind of reset self could be a separate thing, but let's for now just put reset self as part of the fall method. So let's do the modding here again. So mod height.
Cool.
Cool. A trick that an error that a lot of people will fall into is saying, great, I wrote my fall function, let me hit run and see all my raindrops fall. What the heck, no. They're not falling. And that's because, of course, I am just writing the blueprint here. Raindrops know how to fall, but I never told my raindrops, the instances of my raindrops, the raindrops I actually made, I never told them to actually fall. So let me go ahead and do that. Fall. And there they go.
Oh.
I think in my original version, in fact, it didn't have a speed variable. So if I run this now, this is going to break because I'm asking to use the speed variable here. And instead, I think that this is an interesting, this shows how you can use instance variables in multiple ways. I said, I want them, the speed is dependent on the size. So I said, plus this dot size. So this would make the big ones fall faster, which we can go ahead and see. It's probably going too fast. And so let me do this dot size divided by 10. Yeah. Cool.
Yay.
So the big ones are falling faster, the small ones are falling slower. I think that this is a good thing to remember is that I think a lot of people think, hey, my variables can only be used for one thing, or my constructor can only set up variables. Another thing that I could do, that I could have done is I could have said this dot speed equals this dot size divided by 10, and then do this dot speed here. The exact same code, basically. Instead of doing it here, I'm doing it up in the constructor. But yeah, just remember, you have access to any of your tools in your coding tool belt in any of these methods, whether it's the constructor, whether it's a different method like fall. You can be as creative as you want in any of these methods, and yeah, do different things.
Can we try making 2 small style changes here?
Sure.
It's going to be 2 lines of code.
Yes.
So in setup, let's do no stroke. Yeah, anywhere.
Cool.
And then let's
that
run
takes
that.
away the outline, the black outline from the shapes.
And let's do my favorite thing of adding in traces. So in background function.
In the background function.
Let's change background to 255, comma, and let's do 30. Whoa!
Oh my God, Jiwon, you're so good.
I told you it'd be 2 lines.
Immediately way more interesting. That's awesome.
The visual trick.
Let me find what color I used for this background.
Oh yeah, so we can just do that and then just put 30 as the fourth argument. Woohoo!
Yeah. Honestly, yours was better with the white background.
No, I like this.
Yeah. Cool. So we are basically at time. Let me stop here and see if anyone in the chat has any questions. As we wait for questions, Jiwon, what are some of the ways that you would change this or add on to this? What are some further challenges that people could work on?
I think you could definitely explore that adding click function in there. We briefly talked about it in our last live stream session as well. But basically during our last live stream, we experimented with binding key events to create interactions. Actually, that was the one before, but we also did the same thing in that class. So wait a minute, backtracking. We learned how to implement in interaction to our P5JS sketches in the last 2 live stream sessions. So a really good challenge would be, adding in some sort of mouse click event to each individual raindrops. So you could create a whole new method in there. The hints that I'm going to throw out is that you would most likely want to use the mouse is pressed Boolean variable. It's a built-in P5JS variable, which will allow you to check whether a mouse is pressed or not. And then you would also want to check referencing the mouse X and mouse Y built-in variables, and check that against the position values of each of the ellipses. And that way you should be able to detect whether a mouse is pressed and whether when a mouse is pressed, whether the mouse X and mouse Y are within the range of that particular raindrop. And you should be able to have, change color or change the shape or, change opacity, what have you, depending on, whether that, mouse.
Yes, so a super quick demo of this is I wrote this new method. I'm saying if the mouse is pressed and the mouse's X position is to the left, is less than the raindrop's X position, then change the raindrop's blue color to 255. So
that's going to do something really interesting though.
Yes.
We can do it. Let's do it.
For sure. So let's make sure to call our method. What do I call it? Is clicked. Do this and then start clicking. So so let me even restart. So I'm changing all of these ones to blue, but all the ones that my mouse isn't to the left of stay the same. But now if I start to go in this direction, they're all changing blue, which is cool.
We have a quick question from Raphael in the chat and saying, these forms are made with Canvas, right? Could you use SVG? You can't use, well, you could use SVGs by importing them in as an image file, and you could display those image files instead of displaying ellipses in here. If you want to actually control each of the points within the SVG, you're going to most likely going to need another library on top of the V5JS library to manipulate things within the SVG file itself. But you could use SVG or any image files instead of an ellipse in there. So if you wanted to use like PNGs that are in the shape of a raindrop, an actual raindrop with that, the curve going up like that, you could use that instead.
Yeah, and all of that would fall in the display self method of, rather than drawing an ellipse, say, hey, load this PNG or whatever you want to do.
Mm-hmm.
Cool. Great. That's all we have for this session. Again, I will post this solution code in the YouTube description if you want to play around with it. Next week, we are doing a similar thing rather than looking at kind of So in this session, we looked at object-oriented programming through the lens of P5. Next week, we're going to look at machine learning through the lens of P5. So coding up a machine learning algorithm in P5. In fact, let me see if I can find this super quickly, because I think it is a nice thing to get people back. Man.
Machine learning is such a buzzword, though. We could actually, you can combine machine learning with V5JS, and there's another library called ML5, which is also an open source machine learning library that you can use in JavaScript, which is also a good way of exploring. But I think, Alex, you're talking about something a little bit different, right?
Yeah, I'm talking about, oh man, and I don't know if I'm gonna be able to find it quickly. Okay, here it is. Yeah. Give me 1 second. Sorry. Cool. Let me screen share. Cool. This is the thing that we're going to be building, which is the k-nearest neighbor classification algorithm, where this is what we'll be doing next time, of explaining what k-nearest neighbor is and then building out this visualization. So
really interesting.
Yeah, like where my mouse is right now is being classified as light green because its closest points are 2 light green points and 1 dark blue point. So we will get into all of this and much more next week. Cool. Anything else you want to say, G1?
Just want to, we had a question from Charlie about when the next live stream is. It will be next Tuesday, 4 p.m., but it's going to be Eastern Standard Time, 4 p.m.
Cool.
Awesome.
All right, folks. Hope to see you then.